We're going to be reviewing chapters 1 and 2, Alphabet and Grammar of Geometry, and Segments and Angles. It would be helpful if you had your green reference folder out and find chapter 1 and flip through these pages prior to this section as a very brief refresher on basic terminology, equations, and concepts. Chapter 1 starts with an algebra review and graphing of lines. We talk about the alphabet of geometry, points, lines, rays, and planes. We talk about the logic of geometry, inductive and deductive reasoning, and truth tables. We talk about problem solving and brain-in-hand techniques. Now you want to turn to your video review packet for the final, this section. Chapter 2, for the green folder, segments and lines, basic equations, midpoint, slope, and distance, how to draw angles and relationships between angles, parallel lines, alternate in, alternate x, corresponding, consecutive in, equations of lines which are parallel and perpendicular, algebraic proofs, and introduction to geometric proofs. After flipping through those sections, go to this in your review packet. Please note the location and the time that you are watching these videos. Have a calculator handy. We're going to be working through the odd problems, and then you're responsible to do the even problems. Okay, problem number 1. We're going to solve for x first by distributing. Always draw your distributive lines. This is, of course, 10 plus 10x minus 2x plus 22 equals 10x minus 4x. You're going to collect like terms. And your next line is going to read, that's going to be minus 22 there. We're going to have negative 12 plus 8x equals, over here, we're going to have 6x. Bring this over here, we have negative 12 plus 8x equals 6x. Minus 8 both sides, 8x, negative 2x, and negative 12. Divide by negative 2. And of course, x equals 6. When simplifying the radical, do not use a calculator. What you want to do here is you want to factor tree what we have. And this is root 294. So we're going to factor tree. If it's even, it's just easy to do it by 2. So you're going to put a 2 in there. And we get 187. Excuse me, 147. And we check to see if we can't divide this again by 7, which we can. 7 goes in there 2 times, 21. And then we have 3 and 7 again. Now we look at what we can pull out here. We have a pair of 7s. And so they come out. So we're going to have on the outside 4 times 7, which is 28. On the inside, we're going to have 2 times 3, which is 6. And that is as far as we can go there. We can't take 6 apart anymore. When we simplify for radicals, basically you want to treat these as if they're x's and y's. So we're going to collect like terms. So here's 96, and here's 96. And then we have a root 6. And then we have root 5. So we collect like terms. There's a negative 1 there, so there's negative 1 minus 4, so we have negative 5 root 96 minus 3 root 6 minus root 5. And that's as far as you can go. You cannot subtract unlike radicals. For number 7, to simplify, you do not want a radical in the denominator. So we're going to multiply top and bottom by the same radical in order to get rid of it. So this is going to be 7 times 3 at the top. And then root 3 times root 3 technically is root 9. This is root 21. And root 9 is 3. And that's as far as we can go. We cannot simplify root 21. There's no perfect squares in there. So your final answer is root 21 over 3. It says label the diagram with the given information, set up an equation to solve for x, plug in, and solve for all angles. So VUT, VUT is what we're trying to find. So we're going to sweep and put a question mark there. If VUT is 33x plus 1, ZUT is 26, and VUZ is 29x minus 5. We can see that the purple and the green adds up to the red. So we're going to establish relationships first. In this case, the purple angle plus the green angle adds up to the larger red angle. So this is 26 plus 29x minus 5 equals 33x plus 1. We're going to collect like terms where we can. This is going to be 21 plus 29x equals 33x plus 1. Go to minus 29x. Minus 1 both sides. We have 20 equals, this is 2x. In this case, x is 10. Okay, let's check my math here. This, of course, is 4x. Therefore, x is 5. Now we take that value of 5, we're going to plug it in right here. So we have 5 times 33. We have 165 plus 1 means the angle we're looking for, the measure of angle VUT, is going to be 166 degrees. In the next section, we need to identify what kind of angles we have. They're either going to be complementary, linear pairs, vertical, adjacent, alternate in, corresponding, or alternate x. Taking a look at number 11. These are back-to-back. They share a spine and make a line. They're two angles that make a line. Therefore, they are a linear pair. Two angles that share a spine and make a line are a linear pair. We could also describe these as supplementary as well. They are adjacent, but the better description for adjacent in this case is a linear pair. Number 13, A and B. A and B are the infamous armpits of a Z. Therefore, they are considered alternate interior angles. Number 13, number 15. Number 15, A and B actually have two descriptors. They add up to 90, so we will say they are complementary. And they are adjacent. They are complementary and they are adjacent. Number 17, again, they add up to 90 degrees, so they are complementary. And they're back-to-back, so they are adjacent again. Number 19, you have parallel lines. Here is your stir stick, your transversal. A and B are alternate. They're on opposite sides of the transversal, but they're on the outside. So these are considered alternate exterior angles. In this section, you want to list all the information given by the marks on the diagram. This is to test to see how well you can interpret what kind of information is given. So let's first see, these little arrow feathers means that these two lines are parallel. So we would say UW is parallel to XY. That's the first thing that you're being told. The second thing we're being told is that these two angles here are congruent. So angle W, we're going to call this VWU, is congruent to angle VUW going this way. Then over here, we have these two angles congruent. So we're going to say angle XYZ is congruent to angle XZY. And then the last thing is we have a right angle here, and that right angle says that the segment UV is going to be perpendicular. That symbol there means perpendicular to VW. So that represents all the different information that is explained on this diagram. So in 22, you want to list the information that's on the diagram as well. Number 23, you want to find the measure of all possible angles knowing the given information. Well, what we do notice here is we have three parallel lines, and we have a stir stick and a transversal. I'm going to draw that, and I'm going to sweep the angles that we are being given. And we can see that those are alternate exterior angles, and alternate exterior angles are congruent. What else is congruent in this scenario? Alternate interior angles are congruent. Corresponding angles are congruent. And then the oddball would be consecutive interior angles. They're not the ones congruent. They are supplementary. So here we have these two angles are congruent because they're alternate exterior angles. So I'm going to go 10x minus 4 equals 8x plus 14. We're going to solve for x here. So we're going to minus 8x. I'm going to add 4. So I have 2x equals 28, and x equals 14. Now I'm going to plug that 14 back in here. I'm going to get this is 18. And if we divide by 2, x equals 9. Now we take that x, and we're going to plug it in right over here. 10 times 9 is 90, minus 4. We get here 86, which makes this 86. Now we're going to walk our way and find every possible angle that's connected to this transversal. That's 86 because it is vertical. And then here we have armpits of the z going this way, so that's 86. And then this is corresponding, so that whole angle right there is 86. It's also vertical to that right there, that 86. So now we can go like this, and if the whole thing is 180, you take away 86, and you're going to get 94. So this angle right here is going to be 94. This angle here, 94. Which means this angle right here is also 94. This angle 94. This was 86. We have another 94 right here. And yet again another 94 right here. It says find the other endpoint of the line segment with the given endpoint and midpoint. There's a couple ways to do this. There's the algebraic way and the graphing way. Algebraically, since we're dealing with a midpoint, we know if you average the x's and divide by 2, that's going to give you the x, I'm going to call it the xm, the x midpoint. And if you add the y's and divide by 2, that's going to give you the y midpoint. So in this case, algebraically, we have one endpoint of 6, so we have negative 6, plus we do not have our other endpoint. We'll call that x and y. So we're going to go negative 6 plus an unknown x divided by 2 equals our x coordinate midpoint, which is negative 5. You put this over 1, you cross multiply and solve. We end up with negative 6 plus x equals negative 10, and x is going to equal negative 4. And then if we do this with the y's, we're going to have 2 plus y over 2 equals 0. That's your x coordinate, 0. And you put this over 1, cross multiply, so we have 2 plus y equals 0. Y is going to equal negative 2. Now another way you can do this is by imagining this on a number line. So here, if we have the x's, We have negative 6, we have a midpoint of negative 5, and we have an unknown x endpoint. So the distance here is going to be 1 unit. And we have 1 unit this way, and you can see that we're going up the number line, so the position of this x has to be negative 4. And if we go this way, with y, we have positive 2, we have a 0, and we have an unknown y coordinate. The distance here is going to be 2, but you can see technically we're going down the number line here. So 0, if we go 2 units farther down the number line, we're going to be at negative 2. So our other, in number 25, our other endpoint is going to be negative 4, comma, negative 2. Find the distance. To find the distance, we're going to use the distance formula. So we're going to set up a template. You always want to set up a template first, a blank equation, so it's easy just to plug in your numbers. This is x minus x and y minus y. So I circle my x's. I like you to connect with an arrow, left to right. Box your y's, connect with an arrow, left to right. And now we're going to solve. This technically is going to be negative 9 squared. This is negative 11 squared. This is going to be 81 plus 121 square root. We're going to add 81 and 121. That's 2. And the final answer is root 202. That is the distance, which is approximately 14.2. You want to sketch your graph. So in general, you guys are used to looking at y equals mx plus b. So we need to see that there's a couple different ways we need to manipulate this. First off, we need to get rid of the negative, so we're going to times everything by negative 1. I'm going to end up with y equals positive 3 plus 3x. And then we're going to just flip-flop these to get the x in the front. So we're going to work with y equals 3x plus 3. Your intercept is 3. So on the y-axis, you start at 3. My slope is going to be 3 over 1. It's positive, so I know I'm going to go up from left to right. So I go 1, 2, 3, and I'm going to go to the right one. Or I could go down 1, 2, 3, and go to the left one. And you graph your numbers. And that is y equals 3x plus 3. We want to write the slope-intercept equation of a line here. Slope-intercept. So ultimately we're doing y equals mx plus b. But the problem is we can find our slope. Let's find two coordinates here. We have a coordinate here, and that coordinate is going to be over 2 and up 1. And then we have another coordinate here, and that is over 1 and negative 2. So to find the slope, that's going to be y minus y over x minus x. So I subtract my y's. I'm going to go this way. So I'm going to go y, 1 minus negative 2. That's going to be 3. Draw that second arrow. 2 minus 1 is 1. So my slope's going to be 3 over 1. Now I need to find my b. So over here I have y equals mx plus b. Well, I have an x and a y. I could use either one of these points, and I have a slope of 3 over 1. So you can choose either point. I'm going to choose this point right here and plug it in here. So my y is 1. My slope is going to be 3 over 1. My x is going to be 2 plus b, which I don't know. So I have 1 equals 6 plus b. And you minus 6 both sides, and negative 5 is going to equal my b. So the slope-intercept form here is y equals mx plus b. It's going to be y equals 3 over 1 x minus 5. And that is my final answer. We want to write the slope-intercept form of an equation of a line through the given points. Again, slope-intercept is y equals mx plus b. So first we need to find our m. So our m is going to be y minus y over x minus x. Y minus y, I'm going to go negative 5 minus 2 over x minus x. 4 minus 5, that's going to be negative, or let's just write it out, 4 minus 5. So my slope here is going to be negative 7 over negative 1, which is 7 over 1. Now we have to find our b. We're going to choose either point. I'm going to choose this point, 5 and 2. So y equals mx plus b. We're going to plug in our equations here. Our y is going to be 2. Our slope is 7 over 1. Our x is 5 plus b. And we have 2 equals 35 plus b. We're going to minus 35 both sides. And our b is going to equal negative 33. Our final equation then is going to be y equals our m, which is 7 over 1, x minus 33. Here we want to write the slope-intercept equation of a line given the line described. Once again, slope-intercept, y equals mx plus b. We want it to go through this point, but parallel to this line. Now, what do you know about slopes and parallel? Parallel, the slopes are equal. So if we want an equation parallel to this, our given slope that we need to work with is going to be 8. Has to be the same. So our slope's going to be 8. We want it to go through this line, x and y, so now we have to solve for our b. So our y equals negative 3, and then here we have 8, and our x is positive 3 plus an unknown b. We're going to solve -3. We minus 24 both sides, we end up with -27 equals b. Now we have our slope and our b, so we have y equals mx plus b, our equation therefore, of a line which goes through this point but is parallel to that line is going to be y equals 8x minus 27. Our last one, again, we want slope-intercept form, which is y equals mx plus b. We want it to go through this point, but now is perpendicular to this point right here. So perpendicular, what we know about slopes is when they multiply, they're going to equal -1. So the slope that we're given is -1, so we have to ask ourselves what times -1 is -1, and then our desired slope is going to be +1. So our desired slope is going to be +1. We're going to plug this over here. We want it to go through this point. This is x, this is y. So we have, plug in 2 for here. Plug in the slope times x, which is 3, plus b. Now you solve, so we're going to -3 both sides. You end up with -1 equals b. So when you have y equals mx plus b, our final answer here is going to be y equals 1x minus 1. Now you want to go back and work the even problems on your own. Show all your work. When you are done, you can check your answers, but do not look at the answer page until you are done. When you are done, then you go back with a red pen and correct your work. When you get something wrong, make a note in the margin how to do it correctly.